Thank you, Miriam. Hello and welcome to my session, How much camera do you need? What did I learn during my last decades of working experience? Keep things as simple as possible. One goal, one track to reach the goal. There is merely no chance to get lost. Many ways to go and a lot of choices sounds exciting and great, but the goal might be get out of sight and we get lost somewhere in the middle of the track. Things scaled to essentials keep initial cost down. The maintenance is easy to handle. Easy handling means being cost effective. What is needed for a basic machine vision application? Put light onto your object, map the object through the lens into the camera. The camera takes a picture and transfers it to the PC. In the PC, image processing takes place. All of that components are major components and essential for machine vision application. We talk about the key component camera today. All image acquisition devices have lens, sensor and interface in common. Let's have a closer look what's inside. Inside the camera, pixels flow through the pixel pipeline. The pixels start their journey in the sensor. Depending on the camera structure, the pixel flows along the pixel pipeline and passes a couple of interstations. In that interstations, pixels are pre-processed before leaving the camera. In scenario 1, we do pure image data acquisition and output the unprocessed raw pixels. In scenario 2, image data plus image pre-processing is performed. Image pre-processing can be operations like color conversion, hot pixel correction, gamma lookup tables, and so on. Pre-processing can be done in the sensor, an SoC, that's a system on chip, or an FPGA. Let's compare a full-featured camera to a slim camera. What is the best choice? Slim camera's components are a budget sensor and a FIFO buffer capable of collecting some images lines before transferring the data. Full-featured cameras offer large image resolution with tenths of megapixels and speedy sensors. Pixel and image data can be pre-processed and calculated inside the camera. The built-in memory can buffer a couple of images for pre-processing purposes. The images are stored inside the camera until being transmitted successfully to the host PC. The image transition is safe therefore. In the process control can be done by multiple inputs and outputs providing optically isolated trigger and flash, for example. Some housings are even IP65 or 67 protected and are water and dust proof. Slim cameras are small and have little weight. Due to basic electronic components, the power consumption is not that much. The camera stays pretty cool. Indeed, an application in the field of biological research where the camera would heat up and could kill cells. Full-featured cameras with large and fast sensors achieve high data rates and have on-camera processing. The huge amount of data can be effectively be processed within the pixel pipeline and output onto the data stream to the PC. The host PC CPU is relieved and can perform other imaging application tasks like OCR, barcode reading, and so on. Use slim cameras for mobile applications and high-volume budget projects. Kiosk systems that could be photo booth, postcard booth, standard ATMs, passport readers, and so on require just taking a simple picture every now and then. Cameras for augmented reality are handheld or integrated into a helmet that should have a little weight. Only by combining a miniaturized little weight and low power camera, a component processor board and flexible programmable software can tailor-made machine vision applications be developed and embedded directly into machines or vehicles. For example, autonomous transport systems like multicopters for mapping disastrous zones in real time. I talked about this application before. Cameras should not kill cells by heating up the biological experiment. Cooking and biological experiment until it is well done is not a good idea. For multi-camera operation, full-featured cameras are a good fit. They support data handling in simultaneous image acquisition applications. 3D data can be integrated by combining many cameras into one dome. Then the domes are put around a person taking a 3D image. All cameras must make their picture simultaneous at the same time to avoid blurry data. Dustproof cameras are welcome in heavy-duty production lines. As an example of image processing, as an example for pre-processing, we have a look at the color or Bayer conversion of images. What is the impact of transferring raw Bayer data? Less bandwidth. We just have the pixel values. It's the same amount of data as monochrome cameras. Less bandwidth helps to engage multi-camera operation. Image conversion in PC, no FPGA or SoC required. So the camera stays cool. So we talked again about this topic before. When camera pre-processing is done, we have less CPU load in the PC. The CPU can be used for other tasks. The image gets optimized already in the camera, like hot pixel, lookup table, and gamma. The image quality is better when the Bayer color conversions is calculated inside the camera. Some sensors output 10 or 12-bit formats. Also, just 8-bit are required for image data output. The image data source for calculating thus can be up to 12-bit. Accurate calculating is performed with pixel data more than 8-bit. After calculation, the image format is cut down to 8-bit for image transfer. The source data base for Bayer color conversion in the PC is 8-bit raw data transferred from the camera to PC. The source database is less accurate in this case. Since I work in this branch, the PC gets cheaper and more powerful. $1 worth of customer power has grown significantly since the 1980s. You see a linear line, but the axis is logarithmic. PCs and cameras increase their speed all the time. Dedicated features went into SoCs, FPGAs, or even directly sensors. Cheap cost of operation for your dollar is achieved in the PC. What is the software impact for hardware? Software features can be provided instead of hardware features to the camera. There is no need to find another higher-priced camera that offers all required features within the camera hardware. Software running on the PC is more flexible. Software engineers can add extended features in software. As an example, I can think of auto features like auto gain and auto exposure and autofocus. All of them can be operated in the host PC. Let's have a look at our XLE camera. This is a version with housing and with lens. And we also have a camera without housing and S-mount lens, or even a camera with just a sensor without any lens for even lower budgets. IDS went down the path of cost-effective cameras since 2007 when we invented our LE cameras. Since 2020, we offer as a successor the USB 3 version, our XLE camera. That's also a good example for a budget camera with extended software features in our IDS Peak software. Again, here we can have auto features like auto gain, auto exposure, and autofocus. So we went back to our IDS philosophy. Simplicity means efficiency. It's so easy. A development project starts with considering the technical and monetary feasibility. High volume projects are often budget projects. What can be done for staying within the budget? Use essentials or build an every-purpose device? Engineers love to develop perfect systems, but what is really needed? Keep it simple or better than required? There is no need to be overeager. Good enough? No need to be perfect, just good enough. Do not go for more accuracy or faster processing speed than really required. How much camera do I need? So, what is the best choice? A full-featured camera or a slim camera? Finally, the conclusion is either camera. The best fit depends on your application. The camera choice depends on your needs. Simply try to use a camera tailored to your application. Last but not least, a camera needs an appropriate lens. We do not talk about lenses today, although lenses are an important piece for every imaging acquisition device. Learn more about lenses in our Vision channel. Find the right lens later on this year. Sometimes less is more. This session gave you some suggestions how to get a perfect matching industrial camera without blasting your budget. Thank you for your attention and listening to my session.